Program 3. In sample program 2, it starts or reserve the program by pressing the button of table A or table B. In this sample program 3, it provides strobe input in order to prevent erroneous operation. In the button monitoring program, SU_monitor, program selection or program reservation is enabled when the strobe input is turned on. Master program, Master 2, no mechanism. Program description. Begin of program. Init set GB00010 assign 0 to GB0001. Initialize the program reserve A. Set GB00020 assign 0 to GB0002. Initialize the program reserve B. PARACALLSW _ monitor 2 on start the button monitoring program. Loop label for loop. If GB0001 equals 1 then NOP else jump ENDIF1 if GB0001 is 1, program reserve A, then execute the next command. If not, jump to end if 1. Call prog 0201 execute the processing program for table A set GB00010 after completion of the processing program, turn off the program reserve A. ENDIF1 label for jump delay 0.5 if GB0002 equals 1 then NOP else jump ENDIF2 if GB0002 is 1, program reserve B, then execute the next command. If not, jump to end if 2. Call prog 0202 execute the processing program for table B. Set GB00020 after completion of the processing program, turn off the program reserve B. ENDIF2 label for jump. Delay 0.5 jump loop repeat the program, jump to loop. End of program. Button monitoring program, SU_monitor 2, no mechanism. Program description. Begin of program, loop label for loop. Wait underscore if I1 number 0003 equals off T equals O wait for the strobe input to be turned off. No time restrict. TN. Wait underscore if I1 number 0003 equals on T equals O wait for the strobe input to be turned on in the program. Select input to be set. No time restriction. If I1 number 0001 equals on then NOP else jump ENDIF1 if the button A is on, then move on to the next command. If not, jump to end if 1. Set GB00011 turn on the program reserve A. ENDIF1 label for jump. If I1 number 0002 equals on then NOP else jump ENDIF2 if the button B is on, then move on to the next command. If not, jump to end if 2. Set GB00021 turn on the program reserve B. ENDIF2 label for jump. Jump loop repeat the program, jump to loop. End of program appendix. OM10090822E17313. 2. Repeat a program for a preset times and then turn on the lamp to end. 3. In auto operation, shift the torque positions by a preset parameter. Preconditions. Applied processing program, prog 0100, variable to store the program count, GB0001, lamp on output terminal, number 5, number of the program execution, 10 times. Program description 1 set GB000110 sets the program execution time. 2 LABL0001A label for loop action. 3 call prog 0100A command to execute the processing program. The 4th of December GB0001 subtract 1 from the program execution time, GB0001. 5 if GB0001 greater than 0 then jump label 0001, else, NOP. If the program execution time is not equal to 0, go back to LABL0001. If it is equal to 0, then go to the next line. 6 out 01 number 0005 equals on turn on the lamp. 7 stop end of operation, it can be omitted. Preconditions. Variable to store the shift parameter, GB0001, shift the contents in the GD0001 using the shift command. Program description. 1 tool equals 1, TOOL00001. 2 MOVELP1, 10.00 meters per minute 3 shift on robot equals 1, GD0001 starts shift action. 4 MOVELP2, 8.00 meters per minute 5 MOVELP3, 3.00 meters per minute 6 arc set AMP equals 120 volt equals 19.0 S equals 0.50. 7 arc on arc start 1 retry equals 0. 8 MOVELP4, 0.50 meters per minute 9 crater AMP equals 100 volt equals 19.0 T equals 0.00. 10 arc off R send 1 release equals 0. 11 MOVELP5, 5.00 meters per minute 12 shift off ends shift action. 13 MOVELP1, 3.00 meters per minute. This sample program, once started, shifts all points between shift on command and shift off command by GD0001. For example, if the value of GD0001 is x equals 100.00, y equals 0.0 and z equals 0.0, then points P2 to P5 will be shifted 100 mm in x direction on the robot coordinate system. Appendix 314 OM10090882E17. Supplement 1. You can specify the coordinate system the shift will be based on using the argument of the shift on command. Supplement 2. There are 2 ways to change settings of 3D position global variable. 1. Use the menu. Specify the variable name you would like to change. Set X, Y and Z values and click the OK button. 2. Use a sequence command, SCTEL, for example, to change the value of GD0001, X, to 100. SCTEL grand. X1, GD0001 equals 100.00. Robot tool user robot coordinate system tool coordinate system user coordinate system. HARMO, HARMO coordinate system. Rotational system. Teaching order, plus, direction of the external axis rotation. Shift system. Teaching order, plus, direction of the external axis shift. X, Y, Z. TX, TZ tie. 2. U. 2. Rotational center. Center point. Second point. First point. Third point. X. Y. Z. Harmonious coordinates. Origin. Robot coordinates. Y equals ZXX. X equals year XZ. ZR. XR year. Z. Second point. First point. Harmonious coordinates. Set variable. Click. Specify the name. 3D appendix. OM10090882E17315. 4. Count the number of production by counting the number of execution of the processing program and assign to a variable. You can use the counter reset program every morning if you want to count the production of a day, or use it at the beginning of each month if you want to count the production of a month. To see the value of the variable. Preconditions. Variable the production count is to be assigned to GI001, processing program, WORK01 production count program, prog 0001, 1, call WORK01 execute the processing program. 2 inc GI001 add 1 to GI001. Counter reset program, prog 0002 to reset the value of the variable, execute a program, counter reset program to assign O to the variable. 1 set GI001 equals 0 assign O to GI001. Display variable display change view. Click. Appendix. 316 OM10090882E17. 18.2 Application example of CNVSET command. This is a variable type conversion command that assigns a value into a different variable type. 18.2.1 How to add the command. The procedure is the same as other sequence commands. Use a setting dialog box from the Add Command menu. The command is in the Arithmetic Operation Commands group. 1. Setting dialog box. The selectable variable types are GB, LB, GI, LI, GL, LL, GR, LR, GP, X, GP, Y, GP, Z ideographic, P, X, P, Y, P, Z, grand, X, grand, Y, grand, Z, gar, X, gar, Y, gar, Z, GP, G asterisk and P, G, where asterisk asterisk represents an external axis number, such as 1, 2, 3 and 4. For external axis number, only the external axes numbers used in the mechanism of the currently editing program are displayed. It is not possible to register the command if the selected external axis is not used in the mechanism of the editing program. 2. Assignment rules. 3. Errors of CNVSET command, if the variable to assign exceeds the scope of the target variable type. If the specified target variable is invalid. No specified external axis exists due to change in mechanism. Type conversion assignment rule. Original var. Target var. GB, LBGI, LIGL, LLGR, LRGP, PGP, P. Element, grand, element, gar, element. GB, LB concentric circles, hollow circle times hollow circle times hollow circle times hollow circle GI, Lie concentric circles, hollow circle times hollow circle times hollow circle times hollow circle GL, LL concentric circles, hollow circle times hollow circle times hollow circle times hollow circle GR, LR concentric circles times concentric circles times concentric circles GP, P times concentric circles times XYZ times Rob times GP, P, element, concentric circles times concentric circles times concentric circles grand times XYZ times concentric circles times XYZ times grand, element, concentric circles times concentric circles gar times Rob times XYZ times concentric circles times gar, element, concentric circles times concentric circles where concentric circles, assignable. Hollow circle, round off to the closest whole number before assigning to. Times, not assignable. XYZ, only X, Y, or Z coordinate value is assignable. Rob. Only robot articular angle is assignable. Appendix. OM10090882E17317. 4. Supplementary remarks on cut. Copy and paste. When a group of copies or cut sequence commands contains local position type variables, P, the group of commands is pasted in the following manner. Filled circle. The same taught point exists in both commands. Filled circle in other cases. If a group of copied or cut commands contains move commands with local position variables, P, used in the CNVSET command, the local position variables, P, change the variable name when it is pasted. At that time, the teaching point name of the CNVSET command is changed in conjunction with the variable. About the right figure greater than as, P1, has already used in prog 0002, P1, in prog 0001 is changed to P4 when it is pasted in the prog 0002. At that time, the teaching position name of CNVSET command is automatically changed to P4. Tool 1, TOOL1. MOVELP 17.5 meters per minute katakana middle dot. CNVSET1, GR001 equals P. XP1. MOVEPP2. Tool 1, TOOL1. MOVEPP 17.5 meters per minute katakana middle dot. MOVELP 22.5 meters per minute katakana middle dot. MOVELP 30.5 meters per minute katakana middle dot. MOVELP 47.5 meters per minute katakana middle dot. CNVSET1, GR001 equals P. XP4. Prog 0001 Prog 0002. Paste. Copy. If a group of copied or cut commands does not contain move commands with local position variables, P, used in the CNVSET command, the teaching point name of the CNVSET command is erased. About the right figure greater than the teaching point name is erased to avoid any possible errors. P1 in prog 0001 and P1 in prog 0002 are different. Tool 1, TOOL1. MOVELP 17.5 meters per minute katakana middle dot. CNVSET GR1, GR001 equals P. XP1, MOVEPP2. Tool 1, TOOL1. MOVEPP 17.5 meters per minute katakana middle dot. MOVELP 22.5 meters per minute katakana middle dot. MOVELP 30.5 meters per minute katakana middle dot. CNVSET GR1, GR001 equals P. X. Prog 0001 Prog 0002. Paste. Copy appendix. 318 OM10090882E17. 18.3 Application examples of TRANSBASE, TRANSBASV*. Both commands can be used when the touch sensor is used. Use TRANSBASV command in case of using variable to specify the reference point for the rotary shift conversion. 18.3.1 How to add the command. The procedure is the same as other sequence commands, starting from the Add Command menu. Use the dialog box to add commands. It is in the touch sensor commands group. 18.3.2 Sample program. 18.3.3 Supplementary explanation. If the triangle P1, P2, P3 won't match its original form, the triangle P1, P2, P3, then the shifted teaching points are corrected with reference to the shifted reference points in ascending order so that the shapes of those two triangles match. I.e., using the shifted point P1 as the base, correct the point P2 and then P3 so as to create the same triangle as the triangle P1, P2, P3 on the line determined by P1 and P2 and the plane determined by P1, P2 and P3. There is no specific order to assign those three reference points 1, 2 and 3. In case of execution of the command with the repeated operand, the data of the operand will be updated by the newly executed command. The rotary shift executed by the SNSSFT on command ends when the SNSSFT of command is executed. The SNSSFT RST command is a command to clear the rotary shift. If the program is terminated without executing the SNSSFT off or SNSSFT RST command, the rotary shift of the program will be applied to the next program. The error, E2010 sensing not possible, occurs if three reference points have not specified correctly when the TRANSBASE or TRANSBASV command is executed. The rotary shift is applied to the program called by the call command during the rotary shift operation. It is possible to apply the shift buffer data to the rotary shift. As commands are ignored in trace operation, if the operation is switched from auto to trace within the rotary shift section and moved to the out of the rotary shift section in trace operation and then restarted auto operation, then the robot resumes the rotary shift. If the robot is moved into the rotary shift section in trace operation and then restarted auto operation within the rotary shift section, then the rotary shift won't be executed. Those TRANSBASE and TRANSBASV commands can be used together. Specify the 3 reference points for conversion using either TRANSBASE or TRANSBASV command. Execute SNSSFT on to start rotary shift. The rotary shift continues until the SNSSFT off command is executed. The rotary shift to be executed by the SNSSFT on command shifts teaching points so that the shape formed by the shifted reference points, triangle, P1, P2, P3, retain the original form, triangle, P1, P2, P3. Program greater than 1 MOVEL, TRANSBASE1, P1, left pointing arrow, P1, plus sensor shift amount, 2 MOVEL, TRANSBASE2, P2, left pointing arrow, P2, plus sensor shift amount, 3 MOVEL, TRANSBASE3, P3, left pointing arrow, P3, plus sensor shift amount, MOVEL, SNSSFT on. Rotary shift section, MOVEL. MOVEL, SNSSFT off. P3, P1, P2, P3, P2, P1. Shift amount 2, shift amount 1. Shift amount 3. Original. Shifted appendix. OM10090822E17319. 18.4 Application examples of START SLP, CRATER SLP. They are commands for TAWER